Hello friends, I'm Ulhas Joshi. Welcome to my Back to Basics learning series. In every session, I take up a word, a term, or a concept that we use in our daily conversation and work, and I explain that in a simple way for our better understanding. Today we discuss average and standard deviation. We encounter the term average many times in our conversation. For example, the average height of the students in a class is so and so, the average annual rainfall during the past 10 years is so and so, the average number of doctors visited by a company's medical representative is X, and so on. Most of the time, average refers to the simple arithmetic mean. There are other types of averages: median, mode, weighted average, moving weekly average, or moving annual average, and so on. But in this session, we restrict our discussion to only simple arithmetic mean or simple average. For calculating the simple average, we all know that we just add all the data in the list and divide that by the number of data points. When the word average is used in our conversation, we generally consider the average as representative of the data from which it was computed. For example, if the average height of students in the class is 4 feet, then we consider students of this class generally being around 4 feet tall. Similarly, if the number of patients visiting a doctor daily is 35, we generally consider this as the approximately the daily number of patients who are visiting the doctor. But then can we always say that the average number describes the entire data set? Is the average representative of all the data from which it is calculated? To understand this, let us go through an example. The example is that of a pharma company. One of the important activities of a medical representative, an MR of a pharma company, is to visit a planned list of doctors every month and promote the company's product. The company has a norm for the number of visits to be made daily, and the MR needs to ensure that he achieves the daily call average. Some companies expect a call average of 12, some 10, 14, and so on, depending on the products and the work to be carried out by the MR. In our example, the pharma company expects a call average of 10. So for calculating the call average, we add the total number of doctor visits made by the MR during the month and divide that total by the number of working days in the month. So here's some data. The table shows the calls made by three medical representatives, MR1, MR2, and MR3, in the month of January 2022, which has 26 working days. For the call average for MR1, what we do is we take the total number of doctor visits in January, which is 266, and divide it by the number of working days, which is 26, and we get 10.2. Similarly, for MR2, we get the call average as 273 divided by 26, which is 10.5. And for MR3, we get the call average of 8.7, which is 225 divided by 26. So when we assess the MRs based only on the call average, we say MR1 has achieved the call average objective, MR2 has achieved the call average objective, but MR3 has not achieved the call average objective. So on just this parameter call average, the company's action may be: don't worry about MR1 and MR2 and encourage them to continue performing, but reprimand MR3 for underachievement and ensure that he achieves the norm. A closer look at the data will reveal that the above conclusion is a bit superficial. MR1 and MR2 have achieved the call average, but MR1's figure needs a relook. On many days, MR1 has been far from the average. So can we say he is adhering to the call average norm of 10? You can see MR1 has 0 calls on 5 days and 13 to 14 calls on 11 days. So average 10 does not really represent his data. We need to probe more. He missed many working days. Why? He achieved call average of 10 by covering 13 to 14 calls on the many days we work versus expected 10. So is he really meeting the doctors or just making calls to any doctor to achieve his call average? If he meets the right doctors, he is promoting the company's products in the right way. To increase the number of daily calls, is he rushing through his visits on the days he's working? One could also confidentially check the authenticity of his reports and more such questions. So we cannot just go only by the call average. Is there a way to understand data beyond the average? Yes, there is. We need to see the standard deviation of the data and not just conclude based on the average. Standard deviation is a measure of how far away from the average are the individual data. In general, the larger the standard deviation of a data set, the more spread out or more dispersed the individual points are in that set. The formula for standard deviation is here, but to understand this formula, we will go back to our example and calculate the standard deviation. In our example, for MR1, the first step is calculate the average of all the data points, which comes to 10.2. Then we subtract this average from every data point. 13 minus 10.2 equals 2.8, 12 minus 10.2 equals 1.8, and so on. The third step would be you square up the figure which you have just got in step 2. That is 2.8 squared is 7.84, 1.8 squared is 3.24, minus 10.2 square is 104.04, and so on. Then we total up all the squares as step 4. In step 5, we divide the total that you get in step 4 by the number of data points in the data. That is 676.64 divided by 26, which you get 26.024. The next step is you calculate the square root of the number that you get in step 5, and the square root of 26.024 is 5.10. So the standard deviation is 5.10 for MR1. The steps explain the formula for standard deviation. The first step was the average, which is denoted by the Greek alphabet mu. You subtract the average from every data point as step 2. You square that, which is x minus mu the whole squared. You total all the squares, which is the sigma of x minus mu the whole squared. Divide the total that you get in step 4 by the number of data points n. In this case, n is 26. You calculate the square root of that number and you get a figure of 5.10 as the standard deviation. Similarly, for MR2 and MR3, the standard deviation works out to 1.2 and 1.7. Now let us interpret the average and standard deviation of the three MRs. MR1 and MR2, they have a similar call average and seem to be meeting the company's norm of 10. Yes, but the standard deviation of MR1 is almost 4 to 5 times that of MR2. That indicates that the data of MR1 is more widely spread from the average than that of MR2. So the call average of MR1 is not representative of MR1's call data. The higher the standard deviation, the more dispersed the data is from the mean. So this indicates that performance of MR1 and MR2 need to be handled differently, and that MR1 is really not performing as per company norms. Take MR3, the standard deviation MR3 is not large, 1.7. The call average is more or less what represents MR3's performance. So one could study deeper to see why MR3 consistently gets a low call average, and there could be many other reasons. What we have seen in our example is the standard deviation, where we have calculated the standard deviation using all the data of the MRs. We have used the population standard deviation, and this is the formula. If the population is very large and we can take we need to calculate the standard deviation, we take a sample to calculate the standard deviation of the sample and project that to the population. So the formula there slightly changes, where instead of dividing by n, you divide by n minus 1. That's the way the statistics books explain how a sample standard deviation is calculated. We can also calculate standard deviation simply by using an Excel sheet. Use this simple formula. There are functions where you can insert the function in the particular cell and you get the standard deviation. To assimilate what we have discussed, you might like to do some more practice examples yourself using the formula or the Excel method. But it is very likely that you may never need to calculate standard deviation yourself. All that you must remember is that when somebody provides you the average of any data, remember to ask what the standard deviation of the data is. But for those interested in more about standard deviation, a book of statistics will surely explain many more. Such as, you will read that there that standard deviation is a positive number or zero, never negative. One may ask why never negative? Because if it is a square root, there should be a plus or a minus, because the square root is always plus or minus a particular number. But what is explained is that standard deviation refers to the distance or space, that is how far the value is from the average, and distance cannot be negative. So the norm is that it's either 0 or positive. Also, the least standard deviation is 0, and this occurs when every value in that data is the same. Also, some may say that if you want to know how the data is spread, you will find that 68% of the values will lie within one standard deviation of the mean, as is shown in this picture. Roughly 95% will lie within two standard deviations of the mean, and 99% of the values will lie within three standard deviations of the mean. All this is explained in much greater detail in books of statistics. So what we have understood today is that it is not okay to only look at averages. Averages may give us only a partial picture or even a deceptive picture. We need to also consider the standard deviation to prevent us from coming to incorrect conclusions. And to explain the above, see what a stand-up comedian once said about averages. If you put your head and face in the oven and your legs and feet in the freezer, on an average, you would be okay. Thank you. Please like, share, and comment on this video, and please subscribe to the channel if you have not already done so. Thank you.